Now for the second piece, when we're graphing y equals negative x plus 3, I'm going to go back, and again, I'm going to completely ignore that first line, and I'm just graphing the line y equals negative x plus 3, just like we would a normal line. So I'm going to start with my y-intercept, which is 3. So I'm going to go up 1, 2, 3, plot my point. My slope is negative 1. We know negative 1 as a fraction is negative 1 over 1, so I'm going to go down 1 and right 1. And I'm going to do that a couple times. And draw my line. So there's our normal graph of y equals negative x plus 3, but again, we only want the x values that should say x, the x values that are greater than or equal to 1. So again, I'm looking at that line x equals 1, that vertical line, and all of the values of x that are greater than or equal to 1 we know happen to the right of that blue dotted line. So I'm going to go back and erase everything up to that point. And then I have to decide, is that point included at x equals 1? And 1 is equal to 1, so that means I'm just going to fill in that point there for that line, and that's what your graph would look like. So that is option 1 for what you can do to graph. I'm going to show you another method. If you like this better, you can do this instead. The second method we're going to use is pretty much plugging in points. And we know we need 2 points anytime we graph a line. But the points I'm going to use are going to be based off of the restriction values. So if we go back to that first line, y equals 1/2 x plus 3 over 2 for x less than 1. Well, I know I can get infinitely close to 1. So I have to start by plugging in x equals 1 for that line. So if I evaluate f of 1 into that first piece, we know that'd be 1/2 times 1 plus 3/2. 1/2 times 1 is just 1/2. 1/2 plus 3/2 gives me 4/2. And we know 4 over 2 divides to 2. So that ordered pair I just found is 1, 2. I plugged in 1 for x, I got out 2 for y. But we know that 1 doesn't actually exist on this line because 1 is not less than 1. So we show that again by drawing an open circle on 1, 2. From there, you need to pick a second point that actually fits the restriction. So if I want a value that is less than 1, well, a really easy number to plug in then would be 0, right? 0 is less than 1. So I'm going to go 1/2 times 0 plus 3/2, which would give me 0 plus 3/2. So the point that we just found, if I plug in 0 for x, I get out 3/2 for y. And again, I drew an open circle on that first point because 1 is not actually less than 1, but I can get infinitely close to that point. For the second point, 0 is actually less than 1. So that's a real point on our line. So I'm not going to go left or right at all. I'm going to go up 1.5. And then I start at that first point, the restriction value that I plugged in, and draw my line through that point. Okay, so now I'm going to do the same thing for my second line. If I have the line y equals negative x plus 3, my restriction value again is 1. So I am going to plug in 1 again, but to that second piece. And I would get out negative 1 plus 3 is going to give me 2. So the x value I plugged in was 1. The y value I got out was 2. Now this time, 1 is equal to 1. 1 fits that restriction. So I'm going to draw a closed circle on 1, 2. So I'm just going to fill that in if it's already open. And then I have to pick a different point that actually fits that restriction. So a value of x that's greater than 1, I can plug in 2. Again, you could pick any number that's greater than 1. And then I would just plug that in. So negative 2 plus 3 is equal to 1. So when I plugged in 2, I got out 1. Again, that's a real. I'm going to plot that. I'm going to go right 2 and up 1. Start at that first point where we plugged in the restriction value and go through that second point. Again, I don't care which method you choose to use, so you just need to know how to do one of these. But once you know one and feel comfortable with it, stick to it. Okay, second page. This is called a step function, which we've just got essentially a lot more pieces to our graph. So if I have f of x equals 1, f of x equals 2, f of x equals 3, and f of x equals 4, you should end up drawing 4 lines. Now let's think about what those lines really should look like. So I'm going to leave a note here. All of these represent the line. Okay, f of x equals 1, that's the same thing as y equals 1, which we know is a horizontal line. Our slope is 0. Which means that second one really says y equals 2. We've got y equals 3. And y equals 4. So I really just have a bunch of horizontal lines that I'm drawing here. So I'm going to draw my x and y axis. And then I'm going to draw the lines. Again, you could use the eraser method. You could draw all of these horizontal lines and then erase up to the restriction values. I'm going to use the second method here, so I'm going to plug in points. So for f of x equals 1, again, I am ignoring everything else. I'm just looking at this one line right now, f of x equals 1. So if I'm going to graph f of x equals 1, well, that's, again, a horizontal line where y is equal to 1 the whole time. So we know that to be right here. And I lied. I think I'm actually going to use the eraser method for this one. Okay, but I don't want that entire line. I want it to be restricted to x values between 0 and 1. So x equaling 0 we know happens right here. X equaling 1 happens right here. So really, I just want the portion of my line that's between those two points. So I'm going to erase everything up to there. And then I have to decide if my endpoints are included or not. So 0, right, we see that or equal to sign. So that means that value of x is included. So I'm going to use a closed circle. But 1 is just a strict less than, so I'm going to use an open circle on my other endpoint. Okay, so there's our first piece. Now I'm going to look at y equals 2. Okay, we know that's going to be a horizontal line all the way through where every y value is equal to 2. But we want to restrict that to values of x that are between 1 and 2, where 1 is included and 2 is not. So I'm going to erase everything up to where x is equal to 1. And I'm going to erase everything past where x is equal to 2. I'm going to have a closed circle on 1 because it's less than or equal to. And I'm going to have an open circle on 2. Same thing for our next piece. If we have y equals 3, I'm going to have a horizontal line right here at y equals 3. I am only interested in graphing that line for values of x that are between 2 and 3, so I'm going to go back and I'm going to erase everything all the way up to where x is equal to 2. And I'm going to erase everything past x equals 3. Closed circle on 2 because that's included. Open circle on 3 because it's not. And the same thing for y equals 4. I'm going to draw a horizontal line through where where y is equal to 4. I'm only interested in the x values between 3 and 4. 3 is included, 4 is not. And I'm going to erase everything outside of that. There you go. We call this a step function, obviously, because it just looks like a bunch of steps. So the last thing they might ask you to do is they might ask you to to write an equation of a graph for a piecewise function. So however many lines you see on the graph, that should be the number of equations that you are writing. So we're going to start by just looking at this piece here. So I'm going to set up my f of x equals, I'm going to draw my brackets, and I want to write the equation of that line. Well, we know how to write equations of lines, right? We use our y-intercept, we use our slope, and we can see pretty clearly our y-intercept here is at 0, 2. So my b value I know is 2. My slope, you can just count your rise over your run. So if I pick another point, I can see I'm just going up 1, right 1. So that means my slope is 1. And my line is y equals x plus 2. Then we need to include the restriction. So that's only going to be graphed, that line is only going to be graphed if x is less than 0. Right, my x coordinate at that open circle is 0. So everything to the left of that is less than that value. So that's the restriction for that line. If we look at this second piece, again, start with your y-intercept. We can see this one pretty clearly is 0. You can write it in, you don't have to. And then my slope again, I'm counting up 1, right 1, and we get to another point. So I still have a slope of 1, so I'm just going to say 1x or just x. And then this one is restricted to x values that are greater than or equal to 0, because we have that closed point where x is equal to 0, and everything else is graphed to the right of that. If you want to leave a note to yourself at the bottom here of what we're doing there, so to the left of x equals 0, we know the line passes through the points -2, 0, and 0, 2, which is how we get y equals x plus 2. Even if we couldn't see where the y-intercepts were on these lines, we could find slope first using those 2 points. And then once we know slope and at least one of our points, we can always go back and find our y-intercept. So we can do it that way as well. And then to the right of x equals 0, we have the line that passes through 0, 0, and 2, 2. So again, even if I couldn't see where my y-intercept was, we could find slope with those 2 points, and then we could use one of those points and our slope and find the rest of our equation, find our y-intercept. That is all you have. Here is the homework for 2.7. I will see you guys next time.